So let's get this party started. It is week 12, day 2. We're going to continue our discussion of recursion today and proof by induction. Let's go ahead and see how y'all did on the quiz. I was looking at some of them earlier. I think Sarah was the first person to submit an answer on it. And got it correct. Let's see here. So 1, 2, 3, 4, 5, 6, 7, 8 people didn't do it at all. Can't help you if you don't do it. Let's see if I can hide the student names here. Options, hide student names. All right, there we go. There. So prove that the sum of all numbers from 1 to, I assume there's supposed to be an n there. K squared equals n times n plus 1 times 2n plus 1 divided by 6. So base condition first, you plug in 1. 1 squared is 1 on the left hand side. On the right hand, yeah, there you go, there's the left hand side. On the right hand side, you've got 1 times 2 times 3, which is 6. 6 divided by 6 is 1. Base condition checks out. Then for the inductive step, we've got j, okay, j plus 1. So he's already done the substitution. I mean, this is how I would start, by setting it up like this. So we've got the base step proven, and then for the inductive step, we want to prove that this equals this. So assume that it's true for 1 to n, prove that it's true for 1 to n plus 1. And so what we have here is a summation up through k plus 1 squared. And so he substitutes in k plus 1, k plus 2, 2k plus 2. I'm not sure what's going on over here. Looks like he's already done some work up here on it. Plus 1, plus 2, 2, 1. Multiply it out. Oh, I see. Maybe he went this way. Okay. I'm not really following the flow of logic on this. Yeah, I'm not exactly sure how you set this up. Looks like you got the right result better in the algebra, but yeah, not following the setup on this. Like what is J, and where did this come from? Okay. You're still teaching yourself. Okay, fair enough. For this one, okay. So, all right, we'll just go on to the next student. Prove that for every natural number n, okay, let n equals 3. No, you can't really do that. Where is the base case? Like there's two things you need to do to make a proof by induction. You need to prove the base case is true, and you need to prove the inductive step is true. So here's the setup of the problem. Although she had these on the opposite side, it's fine. Equality works that way. Prove that some of all numbers, these should have a square over them, I think. 1 squared plus 2 squared plus 3 squared up through n squared plus n plus 1 squared. I think there's a squared missing there. Equals that. And then here we have, okay, where's the base case? Where's the base case? Yeah, I don't see the base case on here. The inductive step is on here, and she did it correctly. She gathered this up and substituted in the this part here. Right. Anytime you see a dot 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 like that, there's a sign. There's got to be some sort of substitution in there, right? And so that needs a square on it though. Here, which I think she has down here. So substituted here. Multiply both sides by 6. Oh no, it's just multiply by 6 over 6 here. Okay. And then didn't write the base. Yeah, so for all of your proofs, and that's why I gave you a homework assignment, this is just the first 2. So that you can kind of see how to set up these problems. And once you kind of get into the rhythm of things, it's not too hard. But yeah, so this is missing the base case, which is trivial to prove, but you still have to do it. And then for the inductive step, like the setup there is wrong, but yeah, she recovered by putting it in. And then you do algebra, so you just explode out all the algebra, blah 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 blah, and prove that they're the same. Okay. And then for the second one here. Sum of all 2k equals n plus 1. Prove that. Okay, so the ellipses, that sum there, we know what that is. That is n times n plus 1. And then there's one more term at the end there, which is going to be 2 times n plus 1 there. And then the right-hand side, the n turns into n plus 1. The n plus 1 turns into n plus 2. And then you algebra it out, and good. So both of these she did correctly, other than forgetting the little squared there. But both need a base condition proven. The grid thing for trinomials, yeah, that is a cool thing. Okay. Let's see here, and I'm just going to give you points for trying. Everybody who didn't do it gets a 0 though. Sorry. Let's see here. Next. A for effort. Okay. So this is only one of the questions. So no, it's got both of them. Okay. So, alright. So base case 1, check. Okay. And then for the, okay. Okay, so for the algebra here, we assume, I would write next to this, assume this to be true, because that's what we assume to be true. This line right here, the top line, we assume that to be true, right? And then we want to prove this is true here. Okay. And we know what this quantity is here because we assume it to be true, so we substitute that in. And n plus 1, n plus 2, 2 n plus 1. And 2 plus 3, squared, multiply it out, and you get the same number. Good, good. This is a correct proof right here. So first one I'd say is actually correct, even though I usually tend to put the base case first. Just, I don't know, you can do it like that, that's fine. Base case, sum of all numbers that are 2, 4, 6, 8, base 2 times 1 equals 1 times 2. Check. This evacuation is based. I don't know what that means, but I'm sure it means something. This evasion is based. I don't know what that means, but I'm sure whatever it is you said is correct. Equation. I see. That's a cube. Okay. All right. Gotcha. All right. Is based. Okay. Something. All right. So then prove. Okay. And again, I'd write assume this to be true. Assume this to be true. Prove this to be true. All right. So 2, 4, 6, 8, and 2n plus 2n plus 2. So he's already multiplied out the n plus 1. That's fine, I guess. Nope. You put in the n plus 1 on the left side here, but you didn't put it in on the right hand side. So you did here, but yeah, hurts my math brain a little bit. Okay, so we substitute in the things in the parentheses there for that because we know what it is. And then, but yeah, you need to do this part here, up here. Okay. Got the highlight tool. Yeah. That's cool. Highlighted way too much, but that's cool. All right, and then we do algebra, and looks fine to me. Okay. Is base? I don't know what it means. It's provocative though. Okay. All right. K equals 1. Good. I would personally write base condition. Just there. I get what you're getting out there. But it just helps me find. Like I'm looking for 2 checks. Basically when I'm looking at these proofs. Does the base condition check out? Does the inductive sub check out? And here we have, he kind of jumped ahead, but yeah, I'd write assume this to be true, and then he's already kind of substituted in the left half here, but does it? Yeah, and he's already multiplied by 6 over 6. It's fine, I guess. I don't care. K plus 1, K plus 2, 2K plus 3. Again, a little bit of algebraic simplification. And then multiply everything by 6 and simplify it out, and you're done. Okay. And then for this one, base case checks out. For this one, again, I would write assume this to be true, prove this to be true, prior to doing the substitution. And math equals, what is that? 10 squared? 16 squared? What is that? I1C? So you guys have been making fun of my handwriting all semester. This assignment lets me make fun of your handwriting. What is that? Oh, that's K. That's K. Okay. Never mind. I gotcha. Yeah. All right. Yeah. Okay. I see. Literally, it says I see what you're doing. It's okay. All right. So K squared was 3. Yeah. Okay. Yeah. Well done. That looks just fine to me. And base case, good setup here. Inductive step, good. Exactly the right way to set it up. All right. And the handwriting's readable too. I don't know what student this is. So this is as anonymous to me as it is to you. But whoever you are, well done. All right. So good setup. Substitution. Do the thing. Not equal? Not equal? Oh. It was going so well, too. Okay, what happened here? Okay. What went wrong? Alright, so they had the series. That should be an squared. That needs to be a squared. That needs to be a squared there. That's why. Yeah. Whoever it is that uses 5-star paper. After seeing the showing work portion, how much work would you like to see? Like this, except, correct. Right. So that needed to have a squared there. And that's the problem. Because it's the sum of all squares, right? And so the next one in the series is n plus 1 squared. So that's the problem there. Okay, for this one, sum of all 2k equals n plus 1. 1, 2, does it equal that? Yes, it does. Good. Check. Good setup. Again, this is how I kind of like to see it set up. And the amount of algebra you do, somewhere else, somewhat like this, The previous one was skipping ahead a little bit too much because I want to see the setup. Because you can see right here where the problem was. The person didn't put the square on the last term in the series. So if you just start substituting everything at the beginning, it's like I don't know where you screwed up. You want to see a lot of work, just around this much. And by the way, your homework assignment due on Tuesday is a lot of work. Like these are maybe not quite a page for each one. There are 29 problems like this. So, my college experience, is this being recorded? I sure hope so. My college experience was 20 weeks of doing proofs. You guys get a week of it. So, just and one of the questions is wrong. I was talking to Bill Allen, who's this fantastic fellow who retired from the math department a couple years ago. And his son teaches at Columbus North, actually. And I was talking to Bill, and I was like, I like doing proofs by induction with my students, but I just don't have enough problems, He's like, I'll make you some, And so he, like, all those handwritten problems, he just made them for me. And I think there's a typo in one of them, so that you get to find out which one of those is wrong. 20 weeks, 20 weeks of proofs. We didn't do any programming. We did not do a single bit of programming. It was like, graph theory, do Dijkstra's by hand, and you have a table holding the distance to each of the cities, and they start off infinite. Then as you add the nearest city that's the smallest total distance away, you write in its distance, and you update, and everything was by hand. The professor I had was technically a computer science professor, but was a professor by courtesy from the math department or in the math department, one way or the other. So a professor by courtesy is somebody who teaches classes in a different discipline than their own. And I believe she was computer science and a professor by courtesy in math. So she taught math classes and then discrete math for computer science. And when I started teaching it, I was like, I feel like you learn graph theory better if you program graph theory. You know what I mean? Like, and we're gonna probably go back and do some more graph theory because of the low turnout on the Bridges Markov assignment. So we'll probably do some more. We got plenty of time left in the semester. Just do a new Bridges assignment every week until you guys get it. The beatings will continue until morale improves. If you ever seen that on a t-shirt. Yes, 2 straight classes. It's a UCSD semesters are quarters, they're 10 weeks long, and so it's 2 back-to-back quarters of this. And I would just go to the coffee shop and just knock out page after page after page of proofs. And I noticed at the end of it, my computer science did get better, because when you do proofs, you know, it actually does make your programming better. But yeah, you'll see that on T-shirts. It'll, like a pirate T-shirt, it'll say like the beatings will continue until morale improves. Yeah. Like, I don't know if you go to like pirate festivals and things like that. It's one of those classic T-shirts. All right, so here we go. Inductive step. Yeah, okay. That's a good way of setting up, by the way. So, nope. Forgot the times two. So just added an n+1 at the end here. Yeah, so that's not going to work either. Yep. Because if you're adding 2 plus 4 plus 6 plus 8, you know, you can't just like add 5. You know, it's got to be the next number in the series, right? So that's the problem there. But I like the setup. Used to have a unit patch from Korea that said it. Yeah, it's one of those classic phrases. Interesting. Huh. Yeah. The way that the Korean military treats their enlisted people. Did you ever observe that, McCohen? How the Korean superiors treat the enlisted people lower than them in the hierarchy. You were in charge of some, yeah, not you, but like the Korean Korean augmentation to the U.S. Army. No, I mean like the ROK forces and things like that. My Taekwondo instructor was a Taekwondo instructor at the Korean version of West Point for a number of years, and the discipline system is different in Korea than it is in America. So, is it called East Point? That'd be a great name. That'd be a great name. I actually can't remember the name of it. It's like some military academy or something. They're allowed no technology. Yeah, we had an encouragement stick. Yeah. And so you'd walk around, and if your legs aren't the right angle, you'd come by with the stick, everyone would stand up real straight. You know, everyone's posture's got a lot better. Yeah, it's called an encouragement stick. Yeah, it's literally the term. You may request blows on the shoulders by raising the hands in prayer. Gasho is prayer. As the hall monitor passes by with the stick, such requests are typically motivated by pain or by drowsiness, or if somebody's nodding off, they come over and whack him. Yeah. So, yeah, it's a thing. It's not like they're beating you or something, you know. And in America, like Americans don't, like that was a conversation. Like, you know, Americans don't put up with the same level of harshness that they do in Korea. Yeah, so he sort of modified his teaching style for America. Alright, so let's look at the setup here. Okay, base condition. Again, I would probably just put a check next to it just so I can see where your thing is. 1, yeah, I gotta put a check there. Okay. So here you've got the series, and they got the square on it. That's good. Sure, that's a perfectly valid way of setting it up. And then no, you can't do that. That's not allowed. So you just added n+1 to both, n+1 squared to both sides. You can't do that. You just subtract them out, it's substitute, and you get the same thing. No, that's not a legal proof. Do you guys see what n is supposed to become n plus 1, right? So this should be n plus 1 quantity times n plus 1 times quantity 2 times n plus 1. And what the person here did is they just added an n plus 1 squared to both sides and then just subtracted them out and called it a day. So, no, you can't do that. All right, and probably for the same one on this one. So on this one, they did it correctly. Okay. And so we have the series over here that, yeah, I would probably start with this. They left this setup out over here. So there's not quite enough work on this one. But they're substituting out the series with n times n plus 1, are they? Yeah. And then they're adding the next element in the series I would normally put on the right side, just because you would write it that way normally. So 2 times n plus 1, that's correct. That's a correct setup for the left half. And then for the right half, n plus 1 times n plus 2. Yeah, okay. So this is a correct setup. Algebra, chuck. Yeah. This one, no, you can't just do that. You have to substitute n plus 1 for n on all of these. All right. How hard? Not that hard. All right. One more. Base case, good. That's a perfectly fine setup. N equals 1. Left-hand side equals 1. Right-hand side equals 1 times 2 times 3 is 1. True for base case with a ... therefore. Fancy. Nice. Inductive step, assume true for n plus 1. Cool. Okay. So, yeah, that equals, yeah, that's fine. So from r equals 1, or r? K? R? K. R? That looks like an R. K. It's probably K. What do you think? Let's take a poll. It's a K? Alright. So from K equals 1 to n plus 1, we got one more term on here. So they have the square on that one. That's going to substitute out to be the original of this here. And so they're doing the left-hand side here, and the right-hand side is this. Yeah, they've already substituted that out. That's fine. So they gathered out the n plus 1. Okay. 2n, 2k, 2r. I don't know. N, k, r, n. It looks like an n to me. It's an n. It's an n. Okay. Okay. So, yeah, how the table turns. You guys are like, I can't read your handwriting. Oh, fair enough. Fair enough. All right, so we pulled the n plus 1 out, and then you got 2n squared plus n. And you probably gather that. What do you do? Oh, you're factoring. Okay. So it's n plus 1 times 2n n plus 2 plus... does it? Does it really? I'm not seeing it here. I see the factorization, but that's not... There's 3n plus 6. It's not too. Yeah, I'm not seeing it, dude. Like that's not. I mean, as you being a math teacher, yeah. And so a lot of math teachers, just if you want some inside baseball on that, they spot check. So if you turn in like 10 pages of homework, they're going to kind of flip through it and make sure you didn't write poop emojis or whatever on it. Try and BS them. We'll kind of flip through it and make sure you did it all. And then they're going to check like a couple of them and just kind of see if you're on the right track, you know. And then maybe they'll fully grade some of them, you know. It's quite common for all of your homework to get a quick once over and then the trash. Grading is terrible. It's the worst part of being a professor. It's the grading. Yeah. Yeah, do this in Word, right? Use Word's garbage equation editor to type all this up. 29 problems, Microsoft Word. Can I change majors now? Yeah, so yeah, sorry, I don't see that. Maybe I just haven't had enough coffee this morning, but this is not the same as this. So. Okay. I wrote my master's thesis in Word, and that was a mistake. That was an absolute mistake. You change one thing, and the formatting of 110 pages all gets jacked up. You move a pixel 1 inch, and just reflows your entire document. Oh, Lord. It was a mess. And I use section breaks and things like that to kind of constrain the damage and stuff, but and then it would crash, you know, and you have too much stuff in it. And should have done it with LaTeX. So I don't know if you guys know what LaTeX is. It's made. The image is unrelated. That's what. This is not what I was searching for. Okay. So LaTeX was made by a professor named Knuth, who's one of the most famous people in the world as far as computer science goes. So he's a Stanford professor who wrote The Art of Computer Programming, which is finished now? Did he finally come out with it? Yeah. For 2019. Is he done with it? No, not done with it yet. I don't know. Planned, yeah. So I think the clock's ticking on him because the dude's 83 years old. So, you know. But he's probably one of the most famous computer scientists ever, especially if you're talking about people alive right now. And he created LaTeX as a way to sort of programmatically define a Word document, so to speak. You know, it predates Word. But I don't know if most, but like a good chunk of all published scientific papers have LaTeX publication. And they'll usually give you a template to follow. Yeah, if you ever see, that's not exactly what I'm thinking of. Yeah, if you ever see something that looks like that, it's probably, it's so bizarre. It's so, no, I'm trying to, scientific publication, my lord. Yeah, this would be like a classic look for a scientific paper. And if you ever see something kind of laid out this way, from Galway, that's cool. Galway's a beautiful town in Ireland. Highly recommend visiting if you get a chance. It's made in LaTeX. And LaTeX allows you to sort of programmatically define your, paper for submission, things like that. And it's much, much better than Microsoft Word. Much better. Okay. So, I still don't understand why autocorrect is still garbage. Yeah, especially if you're doing computer science stuff. You're trying to type in like, yeah, int I equals 0, and it capitalizes the int, it capitalizes the I. You're like, oh lord, you just have to turn off autocorrect anytime you're doing computer science stuff. Turns on smart quotes, which break your code because C++ doesn't understand smart quotes. Word is better now? No. It's really not. It probably crashes a little less, maybe. No. All right, base case 1. Good. Inductive step. Okay, n plus 1 here. And n becomes n plus 1 here. Yeah, that's correct. Good setup. That turns into 1 to n. That plus the next element in the series is 2 times n plus 1. Good. That's correct. This part here substitutes with this. That's correct. I don't know if that's a 1 or a 2. That's like a Schrodinger's 2 right there. I'm not Trolls, right? Or whatever it's called. I don't know if that's a 1 or a 2. We'll just work with it. Okay, so 2? No? I don't know. I don't know what that is. I'm not following what's... Oh, yeah, okay, that's a 1. And then he's gathering it out here. Okay, and then that becomes n plus 2. Okay. Gotcha. Yeah. Okay. So they're gathering the n plus 1, pulling it over there, and then yeah. Okay. So n plus 1, n plus 2, and that's correct. Yes. Check. All right. So let's do a couple more here in class, and I'm just gonna give points to everybody who even just tried the quiz. No late credit. Do your quizzes. That's what counts as your attendance. Okay. Oh, we can do this later. Okay, so let's look at the homework packet, and we'll do some more. Whenever this loads. So proof by induction is actually kind of fun. Now some of them aren't just series like this, you know. The ones we've been doing have been like mathematical sequences or series or whatever, and those you can basically, there's a pattern for them. You add the next term, the old sequence substitutes in with the old one, and then you algebra. You know, it's pretty easy, honestly. So the more challenging ones are not like just a sequence like that. For example, proved by mathematical induction, 3 times 2 to the nth power minus 1 is divisible by 8. Okay. So how the hell do you do that, right? Because all these, you know, they're basically, all of these are going to follow the same pattern, right? Just add another term to the sequence. The old sequence then becomes that, and you do algebra. So this one though, how do you like, you know? And there's a couple different ways you can do this. So let me now expose myself to criticism and do my handwriting. And so yeah, the factor in divisibility is basically more or less, it's going to work more or less the same way, right? Because when something's a factor, it divides evenly into something, right? So, okay. Do we need to be aware that there's one that won't... with the questions, the wrong question is somewhere within the handwritten sheet that Bill Allen made. Okay. Somewhere within here, there's an error. And I think it's around the mid-section somewhere around here. I don't remember off the top of my head. It was like 13 or something. Yeah. And so the first time I gave it to my students, like they were sitting there and they were just like working on it for hours. Like, I just don't see the answer. They took it into other math professors and they're like, I don't know. I can't figure it out either. And they were just like going to each of the different math professors' office hours, and they finally went to Bill Allen, and he tried solving it. He's like, oh, oops. Yeah, took out some white out. Sorry, the problem was supposed to be this. So to speak. I don't think he actually had literal white out. Sorry about that. Alright, so let's do the proof by induction involving divisibility. So the setup, let's see if I can copy this. Control C and Control V. Proved by MathMill. It didn't copy the equation. Alright, I'll just type it. 3 times 2n minus 1. Okay. There is our thing. Question 6. I'll leave question 6 on there. Okay. So, how do we do it? What's the first thing we do when we do proof by induction? We do a little trolling. It wasn't intentional, you know. And Bill Allen he's a really funny guy, by the way. His wife was the PE instructor, and he was, I think, one of the founding people of the college. And I think it's one of the reasons why so much of the math department is so humorous. Like, we have a pretty funny math department on campus. So I think Bill Allen probably had a lot to do with it. He's a really nice guy. I like him a lot, too. So, oh, you had him before McCone? Yeah. Yeah, base condition. Yes, base condition is the correct answer. So, let's make this a little bigger. Yeah. So, base condition. Best math teacher I've ever had, yeah. Other than this class, of course. I'm kidding. No, he's a much better math teacher than I am. I'm probably better at programming, but yeah, he's definitely a better math teacher. Okay, so base condition is what? What's base condition? But can he teach modular division? I don't think I can teach modular division, given how students have an aneurysm every time I teach it. Blood starts dripping out of their eyes and stuff. N equals 1. Yeah, let's do n equals 1. Why not? Why not? Let's do this. So 3 times 2 to the nth power minus 1, when n is 1, is equal to 3 squared minus 1, which is equal to 8. Okay. Is 8 divisible by 8? So what does it mean for something to be divisible? So for something to be divisible, it's going to be like k is equal to you know, if the number k is divisible by 8, it'll take the form of like 8 times n, right? Something like that. There is some natural number that if you multiply it times 8, it equals that number, right? That's what divisibility means, right? And so for this case, n equals 1, and, well, damn it, I don't want to reuse n. For q, I don't know. So q equals 1, and so it's divisible. Or you don't have to go all that effort, because any person with a brain can see that 8 is divisible by 8. Like, or you just divide it. Yeah, whatever. Yeah, the modulus equals 0. And so the way that modulus is actually defined is like this as well. So the remainder, you take the thing, you multiply and subtract and get a remainder. Yeah. Yeah, so when the remainder is 0, it basically works out the same way. Now for the inductive step, we assume what? Remember, the first thing you always do is you assume what? You assume this to be true. Right? You assume this is true. So we are going to make an ass out of Ume Ume means plum in Japanese, right? You've all heard the phrase, when you assume things, you make an ass out of ume. It's just it's a very deep philosophical statement. So we're going to assume 3 times 2n minus 1 is divisible by 8. And we're going to prove that 3, 2n plus 1 quantity, make sure you put that quantity in there, you're going to have a bad time, minus 1 is divisible by 8. Is there a plum shortage problem? I don't know. But if you guys are over 21, I would highly recommend check if you drink. This is to say, umeshu is my jam. So choya is, you can find this everywhere at every Asian supermarket. They have choya. It's not the best. It's not terrible either, honestly. But they have better kinds of umeshu too. Yeah, I've had choya's better stuff, and it actually does taste a lot better. I haven't had this one. I've had both of these though. And yeah, it's plum wine, and it basically tastes like what it sounds like. So, then they add different things to it: honey, shiso leaf. Yeah. So this is what ume is. Okay. They have some ume trees at the Japanese gardens too. Gives you a terrible hangover. Plum wine, super sweet. Yeah. Okay. If you're under 21, don't drink. All right. So, prove this. So we need to do algebra. Okay. So it's going to be 3 times 2n plus 2. All right. And 2n plus 2. And so, what is the only move we can make here in algebra? Do you guys remember how exponents work? If you add 2 exponents together, what happens? Because remember, whenever you do induction, you're trying to get it to look like this previous thing here, right? Once you can get it to look like the previous thing, then you're basically golden. So what is the only move we can really make here? Separate by multiplication. Yeah, exactly. And so this is the same thing as writing 9 times 2n minus 1. So, looks like we're stuck, right? Because we know that we can't just say this is divisible by 8 and we're done, because that's not how the rules of multiplication work, right? You know what I'm saying? So there is one key observation we need to make about how to get this to work. Substitution? Can't substitute yet. We want to substitute this, but you can't do that because the multiply there, right? You know what I'm saying? What is the key insight? There's silence on Discord, so maybe you don't see it. Maybe I'll make it a little easier on you. You guys remember the opening weeks of this class when we talked about working in Z8? Because we're talking about Z8 here. Divisibility by 8. It's the world of modulus 8. What is 9 in the world of Z8? 1. So I can rewrite this like that. Yeah, a lot of people don't. A lot of people wouldn't get that. Another way you can phrase it is 8 plus 1. You make that quantity 8 plus 1. And 8. And then you'd split it out And yeah, so you could rewrite this if you wouldn't think of that, you could have rewritten this as 8 plus 1 times 3 to the 2n, right? And then 8 times anything is divisible by 8, and the 1 times this, yeah. So you could have probably figured it out a different way also, right? Yoxheimer is having his brain explode. Do you see that? Like, I'll show you the non big brain way of doing it. Right? So this would be 8 times 3 to n plus 1 times 3 to the 2n minus 1. We know that this is divisible by 8 because, look, it's got an 8 there. We know that this is divisible by 8 because that's our assumption. Two numbers that are divisible by 8, if you add them to each other, they're divisible by 8. Done. QED. There, it's math. So not all of them are as easy as the algebraic series. Okay. So a lot of these, and this is why I would spend 10 or 20 hours a week in a coffee shop for my first 2 quarters of college. So I had taken 40 and 41 in high school, and there was a really nice program that UC San Diego offered called Early Admission Honors, where high school students could apply to take college classes in their senior year. And so I took calculus at UCSD, and it was basically kind of guaranteed admission. Like if you had taken first year calculus and you needed second year calculus, they would basically let you in. All right, take second year calculus with us. So I took second year calculus, and then I also took Steve Sci 40 and 41 while I was a senior in high school. And that counts as actual admission into college. So you actually don't have to reapply or anything. They basically let in everybody who was a high school senior that needed, the next math class. It just wasn't offered, outside of the college setting. But it counted as actual admission. So in my senior year of college, I actually got accepted to no colleges. The reason for that was because I was at UCSD already, and I didn't, I liked it. So I didn't, I applied to MIT. I was like, well, if MIT gives me a nice scholarship, I'll go there. But UCSD offered me a full ride, and I was already in, so I was like, I don't really need to apply anywhere else. So I technically got accepted into no colleges my senior year of high school. Did I get a reply from MIT? Yes, I got turned down for early admission, I got turned down for regular admission, and I got turned down for grad school. So, yeah. And I called them up. I'm like, why did I get turned down? And normally, like, I don't think they actually will tell you. But they're like, hang on, we'll pull up your file, and they're like, your grades are good. The interview you gave went fine. Your SAT scores are good. Yep, no reason. I'm like, what do you mean no reason? She's like, we admit 8% of applicants. You were fine. You were just fine. I was like, oh, okay. Yeah, I was like, you can't really argue with it, She's like, yeah, there's nothing you did wrong. We just take very few people. Sorry. So, I'm probably glad I didn't go to MIT though, to be honest. So, I really did like going to UCSD. The weather is just so much nicer. San Diego in the wintertime versus Boston in the wintertime. So much of a difference. Okay. Yeah. Yeah, it was also further for my family and stuff like that. So it was nice having my family around. All right. So yeah. Let's do another one. Divisibility. I'll let you guys do this divisible one because I think now that you see the trick, you could probably do it. But let's do this one. Prove by mathematical induction that 4 is a factor of 5 to the nth power minus 1. 5 to the n. Boston cold, yeah. Like I said, in retrospect, it worked out pretty well. All right, so base condition. Is 4 a factor? Base condition. Prove that 4 is a factor of 5 to the nth power minus 1. For the base condition. Sometimes you'll see people use 0. So that'd be 5 to the 0th power is 1, 1 minus 1 is 0. Technically, 4 is a factor of 0 or something. I don't know. Usually we usually use 1 though. You guys do it. Not me. I put my pin down. N equals 1. Okay. So what is this work out to? Yep. So 5 to the 1 minus 1 equals 4. 4 is a factor of 4. And again, this is the thing of like, k is equal to 4 times q, right? Or whatever. Pick a different variable if you don't like those. So if this number on the left-hand side is a multiple of 4, so it's basically the same thing, as what we did before. All right. So 5 to the 1th power is 5. 5 minus 1 is 4. 4 is indeed a factor of 4. Okay, so inductive step. Assume copy, paste. No, don't do this to me. So we are going to assume this is true. It's divisible by 4, right? And then we want to prove that 5 times n plus 1 minus 1 is divisible by 4. So, what do we do? If you want to make fun of my handwriting, like, now's the time. It's not the most readable. What do we do? What's our move? Whatever we end up with here, we're always trying to put it in terms of what we knew before, because that's the self-similarity principle. That's sort of the underlying philosophical basis for recursion and proof by induction and things like that. Haha, look at his handwriting. All right, well, I know who's getting an F now. Okay. Yeah, break it up again. Yeah, very good. So it's going to be 5 times 5 to the nth power minus 1. Hopefully you guys see the move to make now. Uno reverse card, yeah. Yeah, it's like Mao. Back in the day, Chairman Mao of the PRC issued the 100 flowers or whatever. He's like, I invite criticism from our nation's academics as to what's going wrong with our country and look for solutions to solve it. And then all these people like dunked on him. And he's like, Uno reverse card, everybody who criticized me, Yeah, it's a trap. Nah, it's fine. You're more than welcome to criticize my handwriting. Okay. So what's the move? What's the move here? Anyone? How do we prove that this quantity here is divisible by 4? 5 is equal to 1? Sure. There we go. Done. Okay. Yeah. So in the world of Z4, 5 is congruent to 1. Right? So if you thought that we were like done with modulus, the answer is no. It actually comes up a lot. You'd be surprised how often modulus like rears its head. And yeah. So all right, so I think you guys got those, and it's 7 and 9 are basically the same. Let's see. It's a series. It's a series. I think you did this one already, so you can skip it. I think. Maybe. No. Yeah. This one. This one. So if you've already done it, you can skip those. It's fine. The cubed one. Hint, use the result of 1. Yeah, that's clever. So this one actually has an infinite series on both sides, which is funny. But hopefully you should be able to see some way forward here. Or this one, sorry. So hopefully you guys can use your powers of algebra to figure out number 3. That one's not too bad, I don't think. Easy. Yeah, thanks, Bill. It's easy. Let's see here. Given that, okay, so this terminology you might not be familiar with. So when it says like S sub n, that means like series. You have a series of numbers. So the initial element of the series is 1. S sub 1 is the first element in the series. And the first element of the series is equal to 1 also. It's just coincidence, the index and that's like the index in a vector, you know. Let's do a hard one. Yeah. This is a different one. So prove that S of n is bounded above by 2. So, they actually give the answer. Well, that's nice. I was about to do it. So if S sub 1 is 1, then S sub 2 is equal to 1 plus 7 is 8. 8 divided by 5 is 1.4 or whatever. I don't know. I haven't had enough coffee. 8/5. It's less than 2. So you can't just like do 1 though. You have to do it. You have to prove that for the infinite series, 1.6. Sorry. Right? Yeah, something like that. I haven't had enough coffee. So you have to prove that for every element in the infinite series, none of them will go above 2. And so what you do is you show the base condition. Base condition, 1 is less than 2. Done. Right? Like, pretty easy. 1 is less than 2. And then you assume that it is true for the first k elements. And then, so you're going to assume that S sub k is less than 2. And then you have to prove that it's true for k plus 1. Okay? And so if you just substitute in, well, you can do an inequality like this. That's, how they do it. You can actually put in, like, 2 even. 2 plus 7 is 9. 9 divided by 5 is less than 2. So the highest element it could be is, like, bounded by 2 on top. And if you substitute it in, you get a number less than 2, so it can't be better. He does it using an inequality. So he knows that S sub k plus 7 divided by 5 is less than 2 plus 7 sub 5. 9/5 is less than 2. QED. Done. Let's do a hard one. Okay. You can also prove it's bounded below by 1. Also, you can prove, double quote, double quote, double quote, lim in to the infinite power equals 7/4 using a proof similar to the Fibonacci series. I think we all can see how that would work, so we'll just skip on past that one. Did he give an answer to his own problem? No. Let's see. Let's see. You could 7/4 is 14. Yeah. Okay. That's another summation series. That's easy. For all you guys remember the upside down A, right? We went over that. Backwards E, upside down A. All that terminology I told you, like it just comes up a lot. You guys see it? Upside down A. You know what that means? Forgot. So upside down A means for all. So backwards E. So these are the existential quantifiers. Backwards E means there exists. And upside down A means for all. Yeah. So this means for all n greater than or equal to 2. So, what's the base case here? 1? No. 2? Yes. You guys see that? So he's saying this, if he's asserting that this quantity is true for all values of n greater than or equal to 2, 2 is the base case, not 1. You guys see that? So the base case would be 1 minus 1 over 4, it's 3/4. 3/4, yeah. So base case checks out. You guys understand what this means? And why the base case is not always 1? Because they tell you. I think they tell you right here. Okay. Other than that, and this is multiplication instead of addition. So just be careful of that too. Don't try and solve this using the sigma. Sigma is summation, right? This is the giant pi symbol, mega chad pi. It's multiplication. So they're basically just for loops. Yeah. I'm so glad I'm not as bad as I used to be, because I would have failed this portion of class. Mega Chad Pi. Yeah, that's the official term they use in in mathematics. This one could be fun. Cosine of x plus I times the sine of x to the nth power. I hope you remember your trigonometric identities, because I don't. For all k. So what would the base case be for number 10? You thought you were done with trig functions? I think there's only one on here with trig. Yeah. There's only one trig identity on here. So where was I? Oh yeah. So for number 10, what is the base case for 10? Yeah, 4. For this one, base case is 0, base case is 4. They just tell you. Yeah. And if they don't tell you, it's 1. So it's one of these that has the typo in it. So congruency. Aha. All right. So this is the world of Z9, right? And it's saying for all n that is an element of positive integers. So what is the base case here? Is 0 a positive integer? What's the base case? What n should we pick for our base case? It's not negative. It's also not positive. So there's positive integers, negative integers, and 0. Those are your 3 options. And one of the nice things about doing all these proofs is that you start thinking about that. It's one of the most common bugs that I see in computer science is people use an int, and they just assume the answer is going to be positive, and they just ignore half the numbers, yeah. So the base case is 1, right? Because we normally when we have n, I think there's an assumption it's usually the natural numbers, which start at 1, or the counting numbers. Natural numbers has multiple definitions. Sometimes it starts at 0, sometimes it starts at 1. So by default, though, we typically use 1 here. So how would we prove this? Let's do that one. So we want 4n, we want to prove 4n is congruent to, that's the triple equal sign, 1 plus 3n in the world of Z9. All right. Base case. Prove it. Somebody take it away. Crente, you're up. Crente. Not typing. Garcia, take it away. You're typing. You can do it. N equals 1. Yes. Prove it. Prove it. Yeah. Base case n equals 1. So prove this to be true. 4 is equal to 4. You are absolutely correct. Whenever I did this in real life, I would, whenever students looked really worried, I would pick them for the base case, because they're like, okay, 4 is equal to 4. All right, well done. Applaud. Everyone applaud Tomas, please, everyone. And, all right, you can sit down. And then it's like, all right, McCohen, next, you get the inductive step. Ah, damn it. So, McCohen, you're up. Inductive step. So assume this to be true. We're going to assume this, and then prove it's true for n plus 1. We're going to make an ass out of Ume, and we're going to assume this to be true. Prove it is true for that 4 n plus 1 is congruent to 1 plus 3. Remember the quantity, plus 1. This one doesn't have the same nice feature as before, right? Because this is going to be 4 times 4n, right? So that we don't have the ability to just convert that into a 1 or a 0 or something. Yeah. So what's our move, McCohen? I'll simplify the algebra for you. It's 3n plus 4, I think. Apply the mod to the constants? Can't. That's what I'm saying. Like the previous ones, we were very nicely given like 10 or something like that, and 10 in the world of Z9 would be 1. Unfortunately, with 4, no such luck. Neither can we just like divide it out or something. You'll get a weird fraction or something. So what's our move? Remember, usually when we're doing, well, always pretty much when we're doing proof by induction, is we want to get something in terms of the previous statement, right? Pull out the plus 1 out of the left side exponent. Yeah, I did that here, right? So what's our next move? Substitute in what? What do we substitute in? What do we see down here? The first assumption. Yeah. Okay, fine. Let's go this way. So 4 times, and we're going to substitute 4 to the n. 4 to the n. 4 to the n. So, Now this looks like I made a mistake, but I don't think I did. So let's multiply it out. Let's find out. We get 12n plus 4. Is this congruent to 3n plus 4? Subtract 4 on each side. Is 3n congruent to 12n? What do you guys think? Yep. Welcome to Zn. Z9. Yep, in Z9, 3n and 12n are the same number. Check. Okay. So looked at first like I had made a mistake, but nope. It because we're in the world of Z9, checks out. Good to go. And let's do one more, and then I think we'll just call it for today. I'll give you guys some lab time to work on this, and I'll answer your questions. Anyone, any requests? Basically, we got a bunch of divisibility, modulus stuff, inequality comparison stuff, and then series stuff with either additions or multiplications. 20? $17? $17? You changed your vote. What the heck does 20 even say? The double quote means use the words above. So this is saying prove, you just follow that down. Prove that n cubed minus n is divisible by 3. Base case of 1. Right? And so that would follow the same format that we just did. For 17, it's got a factorial. Yeah, that's a little interesting. For all n greater than or equal to 1, yeah. So it's a normal base case, and it's a mega chad multiply with a factorial. All right, cool. All right, I'll just move it over onto my other screen here. All right, so this is number 17. And so for number 17, we are going to prove that for all k equals 1 to n of 4n minus 2 equals 2n screaming divided by n screaming. Okay, that's a minus. That's not a times. Make that clear. Okay. You might not be surprised how many times I've made algebraic mistakes as I look at that. I'm like, oh, that's a multiply. And why isn't this thing balancing out? Yeah. So yep, you guys understand the setup here. Base case. What? Oh, that's the Giga Chad meme. Mega Chad. One of them. Okay. So the base is for n equals 1. And so this can be 4 times 1 minus 2 equals 2 factorial divided by 1 factorial, which is 1. So 4 times 2 is 4 minus 2 is 2. Okay, there you go. So base case checks out. Inductive step. So we're going to assume this to be true. I'm just going to write assume all that's true. And then we're going to prove it is true for n plus 1. So k equals 1 to n plus 1 of 4n minus 2 equals to remember the quantity screaming over n plus 1. Remember the quantity screaming. Okay, so what side should we do first? Okay. Well, the series here is just going to be the old series from k equals 1 to n, 4n minus 2, times. It's a times, it's not an add, it's a times. It's the product. Okay. Capital pi. All right. So times 4n plus 1, remember the quantity, minus 2. So this, we know what this means, right? We know what value that is. It's right here. So it is 2n factorial over n factorial. That's a quantity. Times 4n plus 1 minus 2. Don't forget the quantity. Okay, this is 17. Yeah. And all that is going to be equal to 2n plus 2 factorial over n plus 1 factorial. Okay, so we're not quite done yet, right? We're not quite done. Couple observations we can make here. Couple different ways we can do this, by the way, for our next move. Anyone want to take a crack at this? Distribute the 4. Interesting. Distribute the 4. Yeah, I mean, sure. Not sure what that'll buy us, but why not? 4n plus 4 minus 2. I'll simplify that out a little bit. Yeah, sure. 4n plus 4 minus 2 is 2. Okay. 4n plus 2. I don't think that does too much, but okay, sure. Why not? Okay, so the 4 has been distributed. 2 in factorial divided by n factorial is not equal to 2. Because that's why I double checked that the parentheses were this way. Because what you're going to have, like imagine you have 1 times 2 times 3 times 10 divided by 1 times 2 times 3 times 4 times 5. Right? The answer is not 2. The answer is 6 times 7 times 8 times 9 times 10. So that's what this is doing here. Yeah, but I like the thought, and maybe writing it out this way might give you some clues as to what kind of move we can do here. Running out of coffee. Class is almost over. Remember, there's going to be a Halloween party tomorrow, Saturday and Sunday. I'll post the schedule of events, and we'll play some Among Us, some Custom Team Fortress, some Age of Empires, Jackbox games, things like that. I'll post the schedule of events, and if you participate, and or post a costume or something, then you will get extra credit points. So forget about graph theory. Do cosplay. That's the lesson for today. Type Racer, yeah, we'll do Type Racer too. That's fine. Okay. So what's our move? Anyone see it? All right, well, what if we multiplied both sides by n factorial? This will cancel out. And this will cancel out that. So if you have like 1 times 2 times 3 times ... times 10, divided by 1 times 2 times 3 dot 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 times 10 times 11. That cancels out, that cancels out. You end up with just the n plus 1 on the bottom. So, all right. Then what is this? If we divide both sides by 2n factorial, how can we cancel this out? Times 1 times 2 times 3 times 10 times 11 times 12 divided by 1 times 2 times 3 times 10 divided by 10 times 10. So these cancel out. You end up with n plus 1 and n plus 2. So that cancels out with that. What? Yep. If you ever confused, just write out the series, what a factorial is, right? We end up with n plus 1 and n plus 2. The n plus 1s cancel out, and we end up with 2 times n plus 2. So, I don't know. Did I make a mistake somewhere? Yeah, so if you have like n plus 1 factorial divided by n factorial, then just write it down, you know, just 1 times 2 times 3 times 4 times n plus 1 divided by 1 times 2 times 3 times 4 times dot 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 times n. All these terms cancel out, right? And so you don't need to memorize like equations, like definitions and things like that. You can sort of recreate them from scratch, right? So this will be equal to just n plus 1. Okay. So 2n plus 2 plus 1. I'm missing a 2 somewhere. So somewhere in here there's a 2 that's missing or something. Plus 4. 2 times that plus 2 divided by plus. I don't know. So somewhere within here I'm missing a 2. But there we go. So that's the idea. Okay. I'll leave this as an exercise to the reader. Or maybe this is one that has an error in it. Who knows? Okay. So that is proof by induction. Hope that was entertaining for you. What is this? What are you getting at here? Wondering if learning proofs could be something that helps with understanding something like this. No, this is partial derivatives, right? From Calc 3, right? So, yeah, I don't think proof by induction would. I don't really know what you're getting at here, but you know, the more math you learn, the better you get at math. So. Yeah, we don't do any calculus in computer science. We do. It's just not very common. About maybe, I don't know, 10-15% of jobs in computer science need calculus. Most of them don't. I've worked jobs where calculus definitely helped. For for example, when making a game engine, if you understand the discretization of time and how, every frame you have to move based on the derivative of the velocity, and like figuring out slopes on curves is actually, calc and stuff like that. And in fact, it's a partial derivative. In fact, figuring out like if you want to put a ball on a surface, which direction does it roll in? That's calc 3, right? So, and then I worked for the bioengineering department doing heart cell simulations, and that was all like differential equations. A lot of biological systems are differential equations, and so in engineering, there's a lot of differential equations in engineering, and the derivative of velocity is acceleration. The derivative of velocity is acceleration, yeah, and the derivative of position, and yeah. So there's a relationship between position and velocity and acceleration and jerk, if you've heard of that, just change in acceleration over time, and then after jerk is... What is after jerk? No. Yeah. Jerk is the change in acceleration over time. So as you put your foot down on the accelerator, right? Something like that. And then there's snap, crackle, and pop. So change in jerk over time is the snap. The change in snap over time is the crackle. The change in crackle over time is the pop. So this is the derivative with respect to time. So yeah. So one of the interesting things about game development is that there's no continuous time in a video game, right? You have a series of frames, and so you have quantized time, which is weird because time in real life isn't quantized, or if it is quantized, it's so small that you can't perceive it. So when you're trying to do physics simulations, and it's not just video games, by the way, it's physics simulations as well. You have to ask yourself, and physics simulations don't need to be real time. You can actually take all the time you want to simulate time. But a lot of these differential equations give you different numbers based on how often you sample them, which seems counterintuitive, right? Because it should be like the more times you sample a physical equation, the more accurate you get. But what happens is that just the numbers change because chaotic systems are chaotic, and there's some things that are like very, very difficult to simulate. If you've ever seen a one of these things at like a science center, you guys know what I'm talking about? Ruben H. Fleet, San Diego represent right there. It's actually really, really hard to simulate that, because as the thing gets faster, it moves further away from the black hole in the center, the gravity well in the center, and so the more often you sample it, you will get different results.
And why is it that the Earth keeps on going around? Is there another rolls over?
There you go.
And so it's that curvature right where it's rolling over that causes that. What's more, Einstein said this.
Yeah. So, simulating physics is actually hard, So usually we kind of ignore it. There's one of them all. Yeah, like they'll roll pennies down it and stuff like that. Yeah. Someone was watching cereal commercials on term naming day. Oh, snap, crackle, and pop. Yeah. Yeah. So yeah. All this math stuff. Like, one of the friends of the family we have, he's a professor, full professor at USC, and his take on it is just the more math you have, the more kinds of problems you can solve. Right? So you don't have to go all the way down the path of being a math major, but just, the more math you take, the more kinds of problems you can solve. And if you can't solve proof by induction, then you're going to be kind of limited in computer science, because you're going to be taking, for one thing, just to pass your classes, right? Like, this is not the only class where you're going to have to do proofs. You're going to do proofs in more classes. And so getting this understanding of like how to lay out a proof and solve it and stuff like that, it's going to be good for you. Because there is a whole branch of computer science called theoretical computer science. And theoretical computer science is for computer science people that actually want to be math majors and not programmers. They sit there and prove things, right? My programming professor was actually a math PhD. His name was Walt Savage. He's the guy who taught me how to program in C++. He died. Oh no. Oh. Sad. Dang. He's died. Oh. Yeah. I know he hadn't been in good health for a while. I wrote to him a while back, but he said my hands aren't working, so I can't really send an email. Which was kind of sad, Yeah, programmers whose hands are jacked up. It does happen, I guess. Carpal tunnel or something. Yeah. So he was a math PhD from Berkeley. And so computer science, the reason why computer science and IS are in different departments is because IS came out of the business department. And so you can learn to program through IS. And you can learn how to do for loops and functions and variables and all that stuff. You can learn all that through the IS department. They teach JavaScript and Java, and we teach C++. And it's the same thing. Like, if you learn Java, you can learn C++ and vice versa, with a minimal amount of retraining necessary. And the reason why we aren't the same department for now, because there's some news coming down the pipeline. There's some big changes in store, actually. Is because the genetic roots of computer science comes from math. And so if you wanted to be a computer science specialist back in the day, you would be a math major with a specialty in computer science. And so that's why we do all these proofs and things like that. And there is a strong emphasis in computer science on being able to prove that your code is correct. So all this proof by induction stuff ties very much in with writing an algorithm and proving that no matter what the input you get is, the output will be correct. Rather than just throwing paint against the wall and just be like, I tested it a few times and it seems to work. It would be really nice if you can prove mathematically that no matter what input you get, your code's correct. And when you take your next theoretical computer science class, you're going to be learning how to do like regular expressions. You might think, well, a regular expression is a very useful. Do you guys know what a regular expression is? Regex. Have you guys seen these before? Yeah, there are changes coming down the line. So, suppose you had a big block of text and you wanted to find every place where there are two spaces after a period but before an uppercase. So this is a regular expression, and so it's a pattern matching thing. So you feed it a block of text and it matches every instance where there is a dot, space, capital letter. Okay? And there's different formats for doing regular expressions. The Unix standard is one, and then JavaScript has its own kind of thing. But the regular expressions are actually the foundation for a regular expression is actually based on theoretical computer science. If you've taken me for 40, you might have seen these state machines before. So when you read a 1, you move from this state to this state. When you read a 1, you move back to this state. And you read a 1, you move to this state. You read a 0, you move to this state. You read a 1, you move to this state. And so, so the fundamental basis of a regular expression to do pattern matching, which is an extremely useful thing. There is a regex library in C++ that is horribly designed, but whatever. It'll do pattern matching for you. Find, you kind of have to understand the theoretical computer science to kind of get at it. And compilers, which parse these giant programs and figure out what you're trying to do, the parsing is also based on something called a context-free grammar, which is also part of theoretical computer science. So when you take theoretical computer science, you're going to be doing proofs, and you're going to prove that this finite automata will generate every alphabet, or something, it'll match all instances where a letter appears 3 times in the same, or something like that. You're doing proofs, and it's just math. It's just like you're writing pen and paper. But if you understand the notion of a finite state machine, then you can understand regular expressions. And if you understand a context-free grammar, then you can understand parsing and how to make a compiler and how to, write a program that finds bugs in your code and stuff like that. Now, Lawton, if you went to his talk, he talked about a parse tree. And so looking at a parse tree to determine if 2 students have the same program for plagiarism detection or for looking for automated homework help and things like that. So that you can't do his work until you've taken theoretical computer science, because that's the fundamental underpinning of it. So all this theoretical stuff is actually practical in practice. They just don't tell you that. And that's the thing that drove me crazy, was because after I learned the Carnot maps, I was like, holy smokes, I can actually make much better if statements now. But nobody ever told me that. Nobody ever told me hey, if you learn De Morgan's law and Carnot mapping and things like that, you can actually simplify an if statement. Nobody gave me a homework assignment like our if homework assignment where you had to pare it down to the middle. No, they're just here's this math thing, and they just kind of left it up to you to make the connections, And so one of the things that I'm very serious about when I teach is sure, I'm teaching you this theoretical stuff De Morgan's law and the laws of Boolean logic and stuff like that, but all of it has really big, because I'm fundamentally a programmer. I want to be able to write code and have the code work, and that I want to make cool stuff. I'm not super hardcore into the theory side of things. I'm interested in theory where there's a real world application to it. So it's in terms of learning and proving how it works and correctness. Yeah, but if you have an algorithm, wouldn't it be nice if you could prove that your algorithm will work? That would be really nice, wouldn't it? Or even better, if somebody gives you some code, if that code came with a proof that it was correct. That'd be nice, And there are some people that do what are called proof carrying codes. So it's actually code that comes with its own proof of correctness. And so you can verify, you can verify that the code does what it says it's doing. And there's security implications and things like that. So you can actually hand somebody a program and you can run the proof and verify it. And then you can look at the proof and be like, all right, this isn't going to delete my hard drive or something, That's cool. So it allows more trustworthy operations and stuff like that. So, yes, things like Carnot mapping, help you write if statements. What we're doing with proof by induction will help you not only write recursive algorithms, but also help you when you go into the upper level theoretical computer science, because that is the underpinning of a lot of things we do. In addition to the finite state machines and context-free grammars, there's something called the Turing Machine. You might have heard of Alan Turing, one of the fathers of computer science. He had a terrible movie made about him called The Imitation Game that came out about 4 years ago. And the notion of a Turing machine is sort of the generalized conception of a computer. And, you know, you'll hear people say the word like Turing complete, like Minecraft is Turing complete. And what they're referring to is a concept, and I think it is, right? Redstone is Turing complete. Is Redstone Turing complete? Yes, okay. So basically, if a machine is Turing complete, that means that any program that you run on any Turing machine could run on Minecraft. So you could build a C++ compiler out of Redstone in Minecraft if you had the time and the will to do so. And people have done ridiculously complicated things like making an ALU, which is the arithmetic logic unit.
Hi guys.
Full screen is unavailable. Let's see this work.
Take that. Now I have the A register. It's less, if the output is less than 6. To get the rest of the sequence. 1, 2, 3, 5. 8. Now.
Yeah, and so it's all this kind of stuff. Yeah, so yeah, Turing complete, you know, and it ties in with Minecraft and like, you know, what is the minimum necessary to have a Turing complete machine? A Turing complete machine can basically run any program if you want to think of it that way. Like all of our machines are basically Turing machines with some limitations on RAM and stuff like that, and that's all theoretical computer science, but it has real world implications. So Savage here, he was a theoretical computer science person who also got into programming and ended up writing a bunch of textbooks. I got some of his textbooks back there. It's kind of behind my monitor, though. I was one of the beta testers for his first C++ textbook, and which was nice because it was all photocopies, and so it was like $10 instead of having to spend, you know, however much money, $80 I think textbook was back then. So yeah, but he was a math guy who got into programming, and it showed. And so I learned a lot of, in my opinion, incorrect things from him. Not incorrect, like, you know, he was teaching that an int is a float or something like that, but he had ideas on how computer science should go that was very kind of theoretical. And when I sort of went out into the real world and became a programmer, I was like, oh, all these ideas are nonsense, you know, especially when it comes to like object-oriented programming and like having all these hierarchies of like objects and things like that. You're going to make an animal class, and you're going to subclass the animal class for like camels and dogs and sheep. And if you need to make a wolf class, then you make a canine class, you subclass the wolf class and the dog class from it. And in reality, no, I just make an animal class and just have a string or something saying if it's a wolf or a camel or something like that. Like, you know, making all these different classes just leads to just unbearable complexity in your code, and it makes it unmaintainable. Although I'm sure there are OO people out there who would pop their monocles at me saying that. Yeah, object-oriented isn't... Class hierarchies, inheritance, there's a use for them, but Savage way overused inheritance, in my opinion. So the changes that are coming is that the school is actually going to reorganize its departments. The school is going to be hiring a new dean, and so I don't think you're going to see any difference from your perspective, but something that I've been kind of wanting to see for a while, which is computer science and IS being in the same department. Yay. Look, the two people that teach programming are now actually going to be in the same room and talking to each other. You know, the people that teach computer security and hacking are going to be in the same department as the people that teach computer science. What a weird and wild concept that is. So I think next year maybe something like that. Like I said, you're from a student's perspective, there's going to be, I don't think, any difference. You're not going to notice. It's mostly just because they're kind of shifting the workload around for the new dean position that's going to be made. So yeah, I don't think you guys will. It'll matter too much, but it kind of will, because with us being in the same department as IS, there's going to be the same dean for those things, and we can start schedule it. Right now, when I schedule my classes, I have to go through two deans because I teach both computer science and IS. You know, I guess I'm a professor of courtesy in IS, something like that, because I teach IS classes for game development, right? And so there's two deans, like one for computer science, one for IS, and you have to like coordinate between the two and stuff like that. And it'll be a little bit easier to set that kind of stuff up. But the main thing is like, I think that we might have more offerings for you at some point in the future. We'll see how that goes. The coronavirus has sort of thrown a monkey wrench in everything, and some things that I wanted to see happen, like having a database class, or having maybe a certificate program, you know, for you get a certificate in programming or something. Data science, it's all kind of on hold right now because of the pandemic. So yeah, we do have computer science classes, but not in computer science. We have computer security classes, but they're not in computer science. So there's a series of 3 classes, which were proposed. I think they've been implemented by now. I was at the meeting where they approved it, and that was like 2 years ago. It was pre-pandemic, so it has to be around, right? I don't know. I mean, who knows? The coronavirus has screwed everything up. But the notion, at least, was that there'd be 3 classes in computer security. One is before you get hacked, so how to secure your system. The other is what happens while you're being hacked. And the other is what happens after you hack, and like doing a post-mortem and forensics and things like that. So the computer security guy that we have is pretty cool dude. I like him a lot. And yeah, I'd recommend checking it out. Stuff like that. So now that we're going to be part of the same department, like maybe we can have more cross discipline, activities and stuff. So yeah. So if you're into security, like I took computer security through computer science. It wasn't IS at my college. It was computer science. And honestly, a lot of these classes could be taught in either. Like, why is Java IS and C++ computer science? There's kind of no rhyme or reason to it. You know what I mean? So hopefully, this reorganization will make things a little bit nicer for you guys. But we'll see. Like I said, like on the surface, nothing will change for you. So your graduation requirements are all the same. Like you're probably not even going to be aware of it, but it is kind of big news. So I want to let you guys know. All right, so that's it for today, guys. Work on the worksheets, and if you get stuck, you can post onto the help center. Like I don't know what move to make here, that kind of thing, and don't post the whole proof. Maybe just like what move should I make here, and you can ask for help and stuff like that. Okay. Are these certificate-based classes or degrees? So IS is career technical. Computer science is academic, which again doesn't make any sense to me because my computer security class was academic, not CTE. But they don't like it's just a weird division, because like what makes something career technical education versus academic? Like I don't know. Like the professors have to be graduates of grad school if you're academic, I guess. CT, you don't have to have a master's to teach. Yeah, it is weird. It's just, I mean, to me, programming is programming, and I don't think you're going to learn a different for loop if you take it in computer science or IS. You know what I mean? Like it's the same thing. So, something like this, discrete math, sure, that's more of an academic thing versus career technical. Sure, yeah. But, yeah, I don't know. So, yeah, most IS stuff is certificate-based, and computer science is degree-based. So you get an associate's degree. And make sure you guys apply for that, because they give me crap if you guys don't get your associate's degrees. Then it's like, why was there a decrease in computer science associate's degrees? And it's like, because nobody cares about it, and I didn't tell them to. So if you're Sit 66 and 41 are the same. Yeah. If you're working for a CompTIA, yeah. Yeah. So, yeah, there's IS classes that teach you routing, so you can get your Cisco certifications. There's a whole bunch of different those. But in computer science, basically our goal is to get you into an associate's degree and to transfer to another college. That's kind of our goal in computer science. Whereas with the IS, it's more to just get you skilled up and certified. You already have a Sec Plus. Yeah. Okay. So that's it for today, guys. I just want to let you guys know about the news and get cracking on it. It's a big homework, and it's going to be a large chunk of your grade. It's the biggest math assignment we have, and the math section of your grade is a third of your total grade. So this proofs homework assignment is going to be, I don't know, 10% of your total grade. I don't know if I'm doing the math right in my head. Something like that. So don't just be like, oh, it seems hard, I'm not going to do it. Yeah, don't do that. I've gone over every class of problem on the homework. So there's division problems, summation problems, multiplication problems, and division modulus problems, right? And that's it. There's only 4 categories, and we've gone over examples of each of them at least once. So again, if you get stuck, post on the Help Center. We can help get you unstuck. But don't just be like, I'm just not going to do it. It seems hard. Because this is something that's like dead serious. This is what I spent 20 weeks doing. So please don't skip this, because then you will have none of that background when you go to Irvine or Santa Cruz or whatever. It's important. And the reason why there's so many questions is so you just get into that groove of like base case, inductive step, rephrase the inductive step in terms of the old step. Sometimes there's a secret move you have to make to unlock the problem, and then once you get into it, then like it just becomes ingrained. And sure, maybe you forget it next semester, that's fine, but at some point when you start doing proofs again, like you get back into the groove again and you'll be fine. Is the CSI associate a joke? It's not, but like companies don't hire based on having an associate's degree in computer science. It's very rare for a company to say associate's degree required. I mean, they might say associates or equivalent experience, like 2 years experience or something. But it's 2 letters you get to put after your name. So you could be Tomas Garcia AS, So AS, BS, MS, PhD. All in computer science. Yeah. Other UC classes will build off what you learn in this class. Yeah. You're not going to get out of doing theoretical computer science unless you just like quit. You're gonna have to get a certain level of comfortability with doing proofs. And if I guess people don't do this homework assignment, then I'll have to come up with some more, because it's actually really important to me that you all do this and you all get into it and know how to phrase it right. Base case, inductive step. I wish there was an AST for computer science. Yeah, it's kind of impossible to have an AST for computer science right now. The people who made the AST kind of cheated when they made it, because there's a cap on how many credits they can go into an AST, and they just wanted to have all of these classes in it. They're like, this is important, and this is important, and this is important. And so what they did was they made not all the classes, but they made like 5 or 6 classes less units than they actually are. So Calc is 4 units instead of 5. CSI 40 is 3 units instead of 4. CSI 41 is 3 units instead of 4. And so we could make our classes 3 units instead of 4 to give an AST, but then you wouldn't be able to transfer to a UC because it's a 4-unit class. And so you can't have a 3-unit class transfer for a 4-unit class. So they wouldn't give you credit for it. So sure, you would have an AST, but then you can't transfer to a UC. And to me, having students able to transfer to a UC is more important than having an AST, because ASTs only work for the CSU system, and you can transfer to a CSU with what we have anyway, because our classes match Fresno State's, right? Been trying to decide which counselor to talk to. Talk to me, dude. I know. Just talk to me. If you have any questions, just ask me about transferring and credits and things like that. Okay. All right. That's it. Thanks, everybody. I will see you guys on Tuesday, or come to the Halloween party this weekend. Have some fun, play some games, do some cosplay or something, earn some extra credit. All right, you've been working hard. It's good to have fun every once in a while. All right, peace out.